I have a second channel, Cube Comp MTDX.
Hey everybody, today I'm going to be testing out these 12 Sony US18650GR 18650 cells from that Dell laptop battery pack. I harvested it last night and I figured these cells were quite old. They're actually from 2003, so they're 16 years old just about. I think the manufacture date was like October 2003, so these are probably the oldest 18650s I've ever harvested from a laptop battery. They're rated for 2200 milliamp hours each. They were configured in a 4 series 3 parallel setup, sort of like what's shown here, but right now the cells are actually facing that way. The biggest reason I harvested this pack was for its nice sturdy case that makes a really nice holder, a very nice tabletop holder. But I figured I would try out these cells and see if they have any usable life in them. Given they're 16 years old, not so sure about that. But they're all sitting between 2.5 to like 3.1 volts, and I'm pretty sure they've been sitting for quite some time since the battery has been last used. And this here is the circuit board that came out of the pack, and it would probably refuse to even bother charging those batteries because of their setting voltages. And what was rather unique about this battery is the fact that it had 2 thermal fuses in series with the positive supply line. Rather interesting. First time I've ever seen something like that. But anyways, I'm going to pop these things in. I have them numbered 1 to 12. So they previously were in not pairs but groups of 3. But of course I'll be using them in pairs if I use them in my cameras. Let's start out with these first 4. So if this is your first time watching me revive cells like this, here's what I do. I load them in a charger and I start them out at a small charging current. Let's say 200 milliamps. And in the case of these being, in the case of the cells having too low a voltage, what this charger will do is it will actually, it'll limit the current down to sometimes as low as 8 milliamps until the cells reach a decent voltage. So anyways, start them out at 200 milliamps until the voltage gets up a little higher. Now number 4 is already up at a pretty decent voltage as it is, starting voltage anyway. So usually these things recover quite rapidly. You can see these have already increased up to 3 volts. Doing this really for just a moment anyway. You can see it's putting about 200 milliamps each into them. We're at 3.11. So this one's already at a pretty reasonable voltage, 3.25. Once these get a little bit higher, I'm going to switch over to 1 amp charge. And they're at 3.16, so what I'm going to do now, increase the charge current to 1 amp, and we'll see what these things can do. As you can see, the voltage on that one has climbed even further, because it already had a higher starting voltage to begin with. And one thing I have to do periodically is check the temperature of the cells, make sure they're not getting hot. The last time I dealt with Sony's, that was an issue. However, it was a different version of these cells. It was actually, I think it was the 2500 milliamp hour cells, or I forget exactly what the capacity was. It was more than these. And it was also from a newer Dell laptop battery too. So, let's see what these 16-year-old cells from 2003 can do. Okay, everybody. The first 4 have charged up, and to my amazement, have a look. It took around 3 hours to charge up. They're fully charged. They're resting at 4.19 volts. They all took around 2100 to 2250 milliamp hours. That's how much they accepted. And they stayed cool to the touch, maybe a little warm, between about 3.8 to 4 volts. But they didn't get hot. They weren't heaters. So yeah, very impressed for cells this age. Now, we haven't gotten to the part where we actually do a discharge test, but I will go ahead and do a little something here. I'm going to change this over to charge test, or quick test rather. Let's see what the internal resistance is on these 4 cells. These are not bad numbers, low 100s, and this is in milliohms, by the way. I didn't realize that last time I was doing a video about this, but so I'm going to pull these 4 out, and we'll start on 5, 6, 7, and 8. So what I'm going to do first is charge these all up. And the reason why I'm going to go ahead and take these off is I'm going to let these things sit for a while and see how much they hold over the course of maybe a couple of days or so. If they keep at least 4.15 or so, then they should be good. So I'm going to set this back over to charge. And I'm going to load in our next 4 cells. This will be 4, 5, 6. Excuse me. This will be 5, 6, 7, and 8. That's right. We discharged up number 4. Now the real test will be when I go to discharge them and see how well they do at 1 amp discharge. How much capacity we get out of them. So now I'm going to charge these up. And one of these on the far right will probably be holding a much lower voltage than the first 3. Excuse me, the next 2. Yeah, I had that wrong. It was the next 2. Actually, I'm going to start these out at full 1 amp. Why not? Because they're all holding at about 3 volts. Or at least that amount. And you can see they've already perked up to over 3 volts, the last two. Okay, so we'll let these charge up and see how they do. Okay, these are done. Let's see how they did. Again, about the same. Between 2170 to 2283, it looked like. Again, very impressive for 16-year-old cells. Now, as mentioned before, the real test will be when we go to load these things with 1 amp discharge. So, before I pull these out, over to a quick test and check their internal resistance. Not too awful bad, at least I think. And again, these numbers are in milliohms. It's the internal resistance of the cells. And pull these out. And we'll be testing the last 4. We'll be charging them up anyway. Okay, and last but not least, cells 9 through 12. And pop those in there and see what we can get out of them. Now these last 3, 9, 11, and 12, they all have, I think, the lowest voltage of the whole group. So we'll see how they do. Hopefully they'll perk up just like the rest of them did. So I'm going to do is I'm going to set the current down because these are so low. Start them at 200 milliamps. Just enough to get them up to about 3 volts or so, then I'll increase the current. And while I'm at it, go ahead and see what the voltages are of our existing cells. You can see they're perking up to about 3 volts already, so go ahead and change the current up to 1 amp. So the first cells that I charged up yesterday, it's been a day now, they're still sitting at 4.17 volts. The first 4. The second group. Still 4.17. They're all very consistent. They're all sitting at 4.17. And what they charged up to seems to be pretty consistent too, but we'll have to see how they do with discharging. I'm really impressed, guys. This is for the age of these cells. These are the best I've ever gotten. So there was the Panasonics that I had harvested back in 2016. They were of a similar age. They came from the same model of computer, same model of Dell laptop. One of the big gigantic ones you could use that would make a nice boat anchor. And also, in 2017, I harvested some Samsung cells out of a big fat compact laptop. I can't remember if it was an 8-cell or a 12-cell pack. I think it was probably an 8-cell. I think it may have had the dummy cells in it too. A lot of those didn't do so great. Had a lot of low voltage cells, and the ones I did manage to recover, the capacity wasn't really all that great. Yeah. These, however, I forgot to mention the Panasonics. I did use those for a while, but they weren't actually all that bad, but they weren't as good of condition as these Sony cells are. But these Sony cells, jeez, I'm really surprised. I was expecting that most of them will probably be sitting at a very low voltage and probably wouldn't perk up very well and wouldn't hold a very good amount of current. But to my surprise, despite being almost 16 years old, these cells have apparently seem to have life left in them. So we're going to let these charge up and see how they do. Okay, so the remaining 4 have completed charging. It took them about 3 hours respectively. They're sitting at 4.18 volts. This one's sitting at 4.17. Between 2162 to 2276, I think was the range. Yeah, pretty consistent overall for all 12 of these cells. That's pretty impressive. Again, I know I've mentioned it already, but these are very impressive results for such old cells. I mean, they're about 16 years old, manufactured in 2003. So I'm going to go and pull these off. And before I start doing the discharge test on these, I got to charge up some other cells that I am regularly using right now. So I'm going to pull these out and load them back into the handy dandy holding tray that I have here. So not only did I gain a nice holding tray from this harvest, but I also gained 12 low to mid-range cells. I guess I can say mid-range would be a better word for as far as their capacity goes. Yeah, not bad. Not bad at all. But the real test will be, again, the discharge test. See how they do with that. And, oh, I forgot. Let me pop these back in there for just a moment. Because I want to do the internal resistance check on them to see what they're reading. So remember, cells 10, 11, and 12 were the lowest voltage of all the cells in this pack. These numbers aren't too bad. I mean, I've seen much worse. So, I think my Panasonic NCR 18650Bs are holding at below 100 milliohms of resistance. But this isn't too bad. At least I think. So that concludes this part of the video. Next part of this video will be loading these things down, which I'll include it in one video on YouTube. It ain't going to be 2 different parts. But yeah, the next phase will be doing capacity tests on discharge. See how they hold up at discharging at 1 amp. Okay, everybody, now we're going to move on to the next phase of this test. And that is discharging these cells and see how much we can pull out of them. They've been sitting for close to a week now. Other things sort of got in the way and just never did discharge them earlier, but Not a bad thing, because that way I can see how well they've held up so far as far as holding their voltage. So I'm going to check the voltages of all these right quick. 4.17, 4.17, 4.17, 4.17, 4.17, 4.17, 4.17, 4.17, 4.17, 4.17, 4.17, and 4.17. So they're all holding 4.17 volts. Very uniform. And as you've seen earlier, the amount that they charged up with, or the amount that I put into them, was about the same for every cell. Roughly their rated capacity. But we'll see how much they do discharging at 1 amp. So go ahead and load 4 into the charger and get started. And set this to discharge. So I'll be discharging all 4 of them at 1 amp each. So let the fun games begin. This is reading as 4.18 volts on all 4. So we'll let this run and see how they do. Okay everybody, the first batch have finished discharging, and this is what we have gotten out of them when pulling 1 amp off the cells. So roughly 2100 milliamp hours, and I was expecting it to be a little bit lower on the discharge versus the charge. Still, for 16-year-old cells, this is quite remarkable. So we're going to move on to the next 4 and repeat. I do have this fan running because this charger was getting a bit hot and the batteries were getting a little warm too, and I think most of it was because of the charger. The little bitty built-in fan was just screaming, so I had this other fan blown across the charger. It always helps when doing a discharge test. I'm going to pop these back into place in their holding bin, because once I'm completely done with them, I'll be charging them back up and putting them into service. And once that happens, I'm going to be doing some reevaluations of my existing cells to see how they're doing, because I think some of my blue LG cells are starting to get a little bit worn out. I'll focus on that later though. So now I'm going to do 5, 6, 7, and 8. Okay, so just like before, just charge them at 1 amp. And we'll let this go and see how these turn out. Okay everybody, the next 4 cells have completed discharging, and look at the results. Still right around the 2100 milliamp hour mark. And again, this was with 1 amp discharge. And if you weren't aware, when you pull higher amounts of current from the cell, the less you'll get out of it as far as milliamp hours goes. So I'd say this is pretty impressive, especially again for 16-year-old cells. So we're going to pull these out and we'll move on to the next ones. And now we'll move on to cells 9, 10, 11, and 12. So cells 10, 11, and 12 were the ones that were discharged to the lowest voltage. I think it was like 2.5 volts. So we'll see how these do when we put a load on them. And just like before, we'll let these go and see how they do. Okay, the third group of cells have finished discharging. Let's see how much we got out of them. They're resting at about 3.5 volts or 3.4 volts. These numbers ain't too bad. These are probably the lower of the group. The ones in the middle are resting. They've gotten 2100 milliamp hours out of them. The ones on the far left and right, roughly, yeah, pretty close to 2100. So yeah, not too bad. Took a little over 2 hours to discharge them. So yeah, not bad. I think that wraps up for this little test. So yeah, to my amazement, these 16-year-old cells are doing quite well. Anyways, hope you guys enjoyed the video. Thanks for watching. Well guys, that's it for this one. But it doesn't have to be. There's plenty more videos on the channel to check out. Also, if you liked the video, please click the like button. And if you absolutely hated it, there is the alternative button as well. But yeah, please subscribe to the channel. I definitely appreciate it. And remember to click the bell so that we get notified of all updates. Also, if you're interested in things aside from computers and technology, check out my second channel. It's CubeCompMTDX. Over there you'll find videos about weather, elevators, bicycling, and pretty much whatever else I figure out to upload. So yeah, anyways, hope you guys enjoyed this video, and thank you for your support.